in this video, I'm going to be showing you how to find inflection points and how to test if they're actually inflection points. So, what's an inflection point? An inflection point is when the concavity changes. Or, this is also analogous to saying when the second derivative changes signs. So when the second derivative changes from negative to positive or positive to negative. So an example of what an inflection point looks like is, let's draw a curve, is some point that looks like so and like so. Right? These are kind of inflection points as an approximation, but why did I choose these points? Well, I chose these points because to the left of this green point right here, you are concave down. You're kind of curling down. Do you see this? You see curling down motion in this graph, therefore you're concave down. And the second derivative is negative. That's why we wrote a negative here. Well, between these two green points, you have a positive second derivative, and it's also concave up. And to the right of this green point, you have a negative second derivative, therefore you are concave down. So negative second derivative stands for concave down, positive second derivative stands for concave up. So, in order to have an inflection point, you must meet two conditions. Of course, the concavity changes, and also your second derivative is equal to 0. Now, this second derivative equal to 0 does not necessarily mean you have an inflection point. That's an important key thing to do. You must test out using a sign chart. So you can use a sign. Let's erase this so we can get more space. You must test using a sign chart. Let's say the function is equal to 0 at some point. You need to test using a sign chart to see whether or not the second derivative changes from positive to negative or negative to positive. If the second derivative change is positive and positive, both on both sides of this equation, where on both sides of the point where your second derivative is equal to 0, then that is not an inflection point. You must check this. This is important. It will for sure be a trick question that you'll see on an exam. So with that being said, let's do some problems. So let's go ahead and find the inflection point for this function. So the first derivative is 3x squared minus 6x. Simply power rule. And the second derivative is equal to 6x minus 6. So it's pretty obvious what the 0 is, right? If you want to find the inflection point, you need to set the second derivative equal to 0. So 6x minus 6 equal to 0. X is just simply equal to 1. So the inflection point is at 1. Let's go ahead and see how the concavity changes using 1. So at x equals 1 here, we want to see what the concavity is to the left and concavity is to the right. So let's go ahead and test that out. What's a number to the left of 1? 0. So let's plug in 0 into your second derivative. If I plug in 0, let's see what happens. Well, if you plug in 0 into your second derivative, you should get negative 6. Therefore, your concavity is downward. So you have a negative second derivative here. So you're concave down to the left of x equals 1. And to the right of x equals 1, pick some number, arbitrary number, doesn't matter, 2. Okay, let's pick 2. So if you plug in 2 into your second derivative, you get 12 minus 6, which is just 6. Positive number. Therefore, you are concave up past x equals negative 1. For this problem, we have to use product rule. So what's product rule? Product rule is, and I'm writing it all down, is equal to f prime times g plus f times g prime. So we'll treat x as f here, and e to the x as g. F prime is 1, and g is just e to the x. So 1 times e to the x plus f, which is just x, times g prime. The derivative of e to the x is just e to the x. Right, so your first derivative is e to the x plus x e to the x. That's your first derivative. Now here's the thing. We need to take the derivative again. Let's go ahead and take the derivative again. Derivative of e to the x is just simply e to the x. And we already calculated the derivative of x e to the x. It's simply e to the x plus x e to the x. All right, using product rule again. So in doing so, we need to we need to set this equal to 0. What we can actually do is simplify this formula a little bit. We can factor out e to the x to get 2 plus x. And when we set this equal to 0, well, since e to the x can never be equal to 0 unless it's e to the negative infinity, you just need to worry about this component of your function. So 2 plus x, when is this equal to 0? Just when x is equal to negative 2. So when x is equal to negative 2, this is an inflection point, and we want to see how the concavity changes. So let's go ahead and check that out. X equals negative 2. What's a number to the right of negative 2? 0. So if we plug in 0 into our second derivative, we should get e to the 0 times 2 plus 0, which is just 2. So we get e to the 0, which is just 1. 1 times 2 is just 2. So you get a positive second derivative. Therefore, the concavity is upwards at x equals negative 2. And how about a number to the this is to the right. 0 is to the right of negative 2. All right, how about some absurdly large number like negative 10? Okay, how about negative 1,000? Doesn't matter. Well, an exponential function will always be positive. So we're going to get some positive number from the e to the power of x. And, well, 2 minus some large-ass number is a negative number. All right? So you get a positive number, e to the negative 1,000. It's still a positive number, times a negative number, which is just a negative number. Doesn't need to know what it is. So you get a negative number. Therefore, you are concave down to the left of negative 2, and concave up to the right of negative 2. Let's go ahead and solve for the inflection points in this problem. And remember, an inflection point only happens when the concavity changes. So let's keep that in mind, only when the concavity changes. So when your first derivative is 8x cubed, your second derivative will be 24x squared. So when is your second derivative equal to 0? Simply when x is equal to 0. So when x is equal to 0, your second derivative is equal to 0. Let's go ahead and test this out. Go use the sign chart. X equals 0. Let's go test the number to the left of 0. So a number to the left of 0 would be negative 1. So f double prime of negative 1 is equal to, well, 24 times negative 1 squared is just 24. Some positive number. And f double prime of 1 is equal to 24 times 1 squared. Still 24. It's positive on both sides. So since the concavity didn't change, we have no inflection points on this graph. Right? You have potential inflection points where your second derivative is equal to 0. But that doesn't necessarily mean it is an inflection point. You must test out for the sign change. That's going to be a trick question very likely on one of your exams, so keep that in mind.